process-based floodplain restoration of bank armoring, or as we have affectionately called it, the Dos Rios Rubble Removal Project. Just briefly, River Partners is a nonprofit organization founded in Chico in 1998. Since then, we've restored over 20,000 acres of floodplain riparian habitats, mostly in agricultural, retired agricultural fields. We're here to talk about a particular phase of restoration work at the Dos Rios Ranch Preserve. This is a 2,100 acre floodplain restoration site at the confluence of the Tuolumne and San Joaquin rivers in Stanislaus County. This is in the middle of becoming the first new California state park, I think in about 16 years. So that's been keeping us all very busy, that transition. Like I said, at the confluence of these rivers, about 10 miles west of Modesto in Stanislaus County. And just a quick sense of our kind of bread and butter work, coming straight out of agriculture, planting at scale, maintaining for several years. You can see the progression from 18 to 22 in one corner of the property. That's field 7 up at the top of the property. And this little overview map, really just to give you a sense of don't use this very often. Hello? Hello? Oh, how about now? How about now? This overview map just gives you a sense. The northern wiggly boundary of the property is the Tuolumne River coming in from the east. The western wiggly boundary of the property is the San Joaquin. So right where they come together. This is a very flood-prone area. Some of the wildlife we've targeted for our restoration work at Dos Rios: Swainson's hawk, the least Bell's vireo, riparian brush rabbit, monarch butterfly, many others. I heard this earlier this week and really liked it. We focus a lot on the imperiled species, but let's keep our common species common as well. So just keep this shot in mind. This is one of the only spots, really the only big spot on the property where we have a natural unarmored bank line where the river is actively meandering into the floodplain, really dynamic new habitat creation, bar formation. That's what we want to see, and that's what we're working towards with this rubble removal project. So we'll circle back to that reference site. So the problem and the opportunity, removal of bank armoring. So private bank armoring and rubble dumping occurs at massive scale throughout the San Joaquin watershed, throughout many of our watersheds in California, but especially the San Joaquin along agricultural lands. It's often unpermitted. It's not engineered. It's not engineered revetment. It's not part of any formal flood control plan. Dumping of this material is technically allowed during flood emergencies, loosely regulated, and it tends to happen all the time. Of course, that drives all kinds of impairments to river function, not just the displacement of bankside habitats and the loss of shaded riverine and aquatic tree canopies and shaded bank lines, but the very purpose of it, to limit erosion and meander so that a farmer's not losing his farmland over time, it's also the thing that cripples the river process, that drives erosion, meander, and generates that early successional riparian habitat that a lot of the species we care about depend on. As the channel simplifies, it incisors unnaturally, moves farther away from the floodplain, and drives further disconnection, getting less water on the floodplain less often for shorter periods of time. Water quality impact. Sometimes there's asphalt mixing in with the stuff. We had all kinds of stuff mixed in with concrete, mostly concrete rubble on the banks of Dos Rios. You're busted up roads often. I mean, anything and everything on hand gets pulled in during flood conditions and dumped on the banks. So the problem's definitely been identified. A lot of regional conservation plans that include revetment removal as a goal. The Central Valley Flood Protection Plan's conservation strategy, for example, identifies 50 miles of revetment removal as a goal, a major goal in the plan. Almost none's been completed to date. We're really happy to contribute this mile of removal at Dos Rios. But I think here mainly, rubble problem, what we'd like to see here in the images, and then just looking at this chart in the upper right. These are from the conservation strategy from the Central Valley Flood Protection Plan. And looking at that natural bank chart in particular, the data is incomplete, but you can see they still took a stab at estimating existing natural bank and opportunity for more natural bank, but hardly even show up on the chart. San Joaquin's one of the most imperiled rivers probably on the continent, and this is really, I think, displays that. So a little bit about the river reach. We're right in the bottomlands, so we're well below the cobbly spawning reaches of the tributaries like the Tuolumne. This is a sand-bedded river, highly sinuous, very low gradient, was very dynamic channel movement over time, at least up until the mid 20th century. Mainly here, kind of a cool channel alignment comparison over time. I think the big thing to just notice is you can see significant differences between the tan 1860 river corridor and the 1915 river corridor, but almost total overlap from the 69 in green to 2010 in blue, since we started locking up the river, all this revetment, took the peak off the flood cycles with all our dams and so on. Then just a cool shot of the kind of thing we want to see, driving floodplain process here, some big deposits after the 97 flood on the property that really stick out. Of course, all that just got pulled back off by the farmer, but going forward, that's the kind of thing we welcome on the site. Since the flood conditions, flooding sticks around for a long time at Dos Rios. In 2023, the most recent big flood out here, water was on the property pretty much continuously from January to June. So we have really extended flood periods. And as you can see some shots here of some of our restoration fields. And then in the upper right, just a good example of a bank failure during that. Actually, that was at the 2017 flood. The river ripped through an armored bank, which typically all these farmlands in this area also have artificial berms constructed on the bank lines, raising that bank line even further, and then rubble and armoring on them. The river blew through, started to rework the floodplain surface, some scour holes, some nice variety of topography. Again, that's what we want to see. So here's our reference meander site on the property. Just a nice little graphic showing the progression here. It was pretty much locked in place for decades, and then the 2017 flood broke through the bank here, and then in just 3 years, the lime green, dark orange to gold lines, that's a 3-year progression, about 200 feet of meander following that 2017 flood. So once that process gets uncorked, the river starts to chase that new equilibrium and it can progress pretty quickly. So with the help of the DWR Riparian Stewardship Program, which provided funding for planning and permitting the project, we mapped all the rubble on site, worked through a prioritization process, few key parameters that guided that. And if you were ever thinking about a project like this, some simple things that we look for. We couldn't afford to remove it all, right? We're often constrained. And so picking rubble removal sites on the outer bends of the river where we have fairly high velocities and shear stresses, and so high meander potential, locations that tied in with other restoration features on site like swales, remnant wetlands, and of course, good access for our heavy equipment was an important logistical layer that we had to put on top of that. So we ended up selecting 6 work sites, shown on this map on the left, total of about a mile of bank line, about 10,000 cubic yards of concrete trash was our final scope. Lots of surveys, lineations, a lot of work to support all our planning and permitting here. And I guess without any further ado, in late summer, fall 2024, we were finally able to start the Dos Rios rubble removal project. This was, so we'll have a few nice before afters. Basically a couple of long arm excavators and dump trucks. Here's the same site afterward, a little before after again. Some sport vehicles, refueling and pickups and so on. But basically 2 long arm excavators and a couple dump trucks. And we just got to work. Took about 6 weeks to work through these sites. There's another before shot. And after, you can see the rubble still piled up in a big windrow up on the bank. We had to finish all the rubble removal from the banks and the in-water work by October 31st. It's an important salmonid migratory period to wrap up by. So we first prioritized pulling it up onto the floodplain, get it off the banks, and then We actually cleared that Halloween deadline by about a week and a half and started hauling the material off the floodplain to a couple locations on site where it's now staged, waiting to be crushed into road base. And hopefully the state park can just draw from that for years to come for road resurfacing. The landfilling alone for this 10,000 yards would have been about 1.2 million. And that was more than the cost of the full removal effort. So we were pretty determined to find a way to leave it on site, but also crush it and prevent it from ever going back out onto the river. Yeah, I mean, a range of avoidance minimization measures were included. We had extended negotiations with the water board. We did this work under the new statewide restoration general order with the water board for 401 compliance. Big fan of that program. Went really smoothly. Thank you to the water board, our regional board, for working with us on this and coming to terms with the fact that the point of the project was to induce erosion and to find ways to navigate that within Section 401 and Clean Water Act compliance. Some cool work measures as well, just trying to be safe for the wildlife. Things like as the excavator was removing material along the water line or just down in the water, we were only removing material that the operator could see. We weren't chasing material out into the riverbed. And so things just like tapping the bucket on the water before it enters, giving any fish nearby a chance to clear off. The work went shockingly smoothly. Like I said, we finished about a week and a half early on the actual removal phase. Didn't really run into any strange or unexpected material other than pipes and asphalt. Like I said, most of this was concrete. My colleagues Leah Young Chung and Diego Garcia with our water quality monitoring probe. So watching these sites daily, taking water quality measurements, and essentially just trying to ensure minimal disturbance that we could. Procedures, SWIP requirements, and so on. So after we got all the material off, we broadcast seeded a group of forbaceous species. We use a lot on this property, some local ecotypes of mugwort and primrose and gum plant, spread native straw, and planted about 500 pole cuttings of cottonwood and a couple species of willow. You can see them prepped in the buckets here. Riparia, the bank swallow. Now functionally gone from the San Joaquin Basin in no small part due to the dramatic decrease in natural bank lines like this, where they make their home. So certainly at River Partners, we are already planning on additional rubble removal projects and hope to complete enough in this river reach where we work a lot. Maybe one day, Riparia will move back in, thrive again. So I guess a couple key takeaways I just want to share. Hopefully this helps get more of this needed work done. Obviously we need to thoroughly plan and scope these projects, but I think sometimes in this case, we're pulling trash off the riverbank. Don't have to overthink it. We want to prioritize work sites and everything, but a little bit of this project suffered from a little bit of analysis paralysis in those early years. Pick those primary parameters that we're planning around and move ahead. There was also a little bit of hesitation to really engage with the regulators, but at the end of the day, I just started to work with the Army Corps 404 division. We discovered together that the Army Corps would not require permits for cleaning trash off the riverbank, despite working on the water line and the ordinary high water mark and in waters of the U.S. No placement of fill, no placement of dredge material. We were able to navigate this project without a 404 authorization. And those are the kinds of conversations have early, include in the project scope. And I found that folks were willing to collaborate and help us find a good way to get this thing permitted and done. And finally, probably the most important point here, private and unpermitted material on these rivers is plentiful. Much easier to remove than trying to work with the state and the feds to remove formally placed engineered revetment as part of a plan of flood control. We get the same benefits for removing a mile of this informal trash as we do those engineered revetment sites. And often those are protecting sites that can't suffer the meander, say in more urban areas or whatever. So I would say what we hope to share and what we'll be doing more of is targeting this privately placed unpermitted crap for removal off the riverbank. And I think I'm probably pretty much at time, but I just a quick, during 2024, 25 flooding on the Tuolumne, and then on the right after that flooded past. A little bit of reworking of the floodplain. I think this will be a dynamic spot for years to come, but not a major flood. But even in that first winter, we saw bank top elevations drop about 3 to 4 feet and starting to get some really nice. Here's the same site looking west across Dos Rios. Dropping that bank top elevation is what we want to see. Get more water on the floodplain more often and for longer. So, yeah, thank you.
All right, moment while we set up our second episode of this session. It's Hacking the Seeds. All right, let's see. Exit out with a right click, or actually, where's the mouse on here? Oh, that's fun. Oh, no, I'm just trying to find the mouse to close this off, but
It's on that screen right there.
oh, it is. Dang. Invisible. There we go. There we go.
Yep. See you right here.
Will be with Haleigh Holgate. This is Wilson's. Anyway, it should be opened up. There's multiple tabs.
Yeah,
There we go. The third one, very well.
yeah, present up there.
Yay. Nice.
Yeah.
So,
We're clicking on these things, and it's just a laser.
Yep.
Wow. Very good.
oh, you turned this on. Oh, you're both going together. This makes more sense. Here, open up the back. All right, thank you all for your patience. Here we go with our second round of presentations, Sowing the Seeds of Certainty in the San Joaquin Valley and Tulare Basin, being presented by Haleigh Holgate and Annie Booth. A little bit of bios of them. Annie is a restoration ecologist with River Partners and works in the Modesto area. Haleigh is a wildland seed collector with Heritage Growers, seed arm of River Partners, and works across the state of California collecting seeds in various ecosystems. Take it away.
Well, I guess the River Partners session continues. We're excited to talk to you about the story of sowing the seeds of certainty in the San Joaquin Valley and Tulare Basin.
Okay, and we're gonna jump back and forth because we're in this together. So, thank you, Haleigh. Just so Neil just familiarized ourselves with the banks of the San Joaquin River. So I just wanted to zoom back out for a second. And if you look at the northern end of the valley, you've got the San Joaquin River, second longest river in California. I'd argue it's the hardest working river. And it actually flows north where it meets the Sacramento River and the Delta and then flows out into the bay. And then if you look at the southern half of the valley, you've got what we call the Tulare Basin. And rivers like the King River, the Kaweah, the Kern, they all don't reach the ocean. They end inland at what was historically the Tulare Lake. So habitat loss. If you drive through the San Joaquin Valley today, you're going to see miles and miles of agricultural land. And it's one of the world's most productive agricultural regions, but it's come at a cost. What we don't see today is these vast areas of riparian habitat and grasslands and wetlands, because we just fundamentally altered this system. And you see on the map here that we've lost almost 90% of the native habitat. So just to go into a little bit more about what we do here at River Partners, basically we take what you see here on the right and we turn it into what you're seeing on the left. We plant native plants at scale and we try and reconnect the rivers back to their floodplains.
So today we're going to be talking about work that we've been doing over the past few years under a state-funded grant by the Wildlife Conservation Board. River Partners secured $40 million in that state funding in fall of 2023. And the goal is to restore rivers, floodplains, and riparian forests across the Central Valley. A little bit more of a detailed goal is that we were intending to deliver at least 10 shovel-ready restoration projects and advance native seed research and development across this region by March of 2026. I put this map here on the right-hand side just to show you all the counties that are highlighted of this region. We've been collecting seed in this region and then trucking it all the way up to the Heritage Growers Farm in Colusa County, where we are amplifying all of that seed. Then throughout this talk here today, the theme that we're really kind of honing in on is that shovel ready goes beyond the plans and permits, and it really means having a native seed supply to support and restore these 6,000 acres.
All right, so what's stopping us from increasing the pace and scale of restoration? In the past, we've broken through so many different bottlenecks. We have, there's a lot of funding opportunities out there. We have community support and political will. We have agency backing through programs like cutting the green tape. And then we have the proven farming methods. We know how to plant the plants and get them to thrive. But what you see here in the bottle are what still kind of restrain our work. And water constraints is a big one in the valley. I don't have time. It's a deep dive for another day. But we're focused on here is how do we unlock the native seed supply.
So this region of California was historically defined by these ecosystem types here. Like Neil mentioned earlier, River Partners' bread and butter is riparian forest restoration. And this grant has allowed us to expand into these new geographic areas of this region, figuring out how to restore and reconnect these systems like grasslands, alkali scrub, and vermipools.
Okay, so now imagine you're handed this blank canvas, and in our case, this campus was thousands of acres of agricultural land. So the first question we had to ask ourselves is, well, what plant species do we actually want to have? What do we want to wish for? So we started by doing a lot of background research on vegetation alliances and visited our remnant and reference sites to see what species are actually growing out there on the land. And then we had to go to all of our project sites and understand what the soil conditions are like, what the flood dynamics are like, and what the depth of water table, anything that would influence the species composition on the site. And then, of course, we had to develop our driving goals. Maybe one project really had to target wildlife species. And so we had to predict what plant would be good or benefit that targeted wildlife species to put out onto the land. And of course, we're focused on native plant biodiversity recovery.
Okay, so Annie and team puts together these wish lists, and Heritage Growers' job in all of this is to figure out how to make that wish list a reality. As we all are in here as practitioners, designers, planners, permitters, producers, and alike, we could all probably reflect on a time where we weren't able to get the materials that we needed for a project in the timeline that we needed. This is a common issue that I think can, in one way, be alleviated if we just allowed producers enough time to actually go through and produce the materials you need. What was interesting about this grant here is that River Partners is planning and permitting these shovel-ready projects while simultaneously Heritage Growers is collecting and amplifying seed for these large-scale projects. So we were able to kind of tease apart how you alleviate a bottleneck for a really large region of California. Some of the things that we walked through that process is what you see on the screen here. First, we kind of assessed the regional availability of seed out there, and then we prioritized species that weren't actually available in the quantities that we needed them. We went out and got boots on the ground. We found remnant populations. We, built new partnerships and enhanced existing partnerships to unlock new collection opportunities. Through our scouting, we then identified where and which species occur in large stands. Because we are putting a lot of this wildland seed into a conventional agricultural production, we needed to collect large quantities of seed, but making sure that we're ethically doing that so we're not hurting wild populations out in this valley. And then, of course, seed biology is kind of important to consider here too. Orthodox seeds are, like grasses and forbs. You can dry, store, and amplify them versus recalcitrant seeds like acorns and buckeye have a high moisture content in storage and really are often only collected the year prior to implementation. And through this, we kind of got an understanding of how long it's really going to take for us to collect and amplify all the seed needed for these 12 restoration projects. So we had 2 years of collecting seed, and these 2 years also amplifying seed. We produce about 850 bulk pounds, which comes out to 600 PLS pounds. This is a cool metric to kind of understand how long it's going to take for us to get, all the seed on these huge restoration projects. And then I got really excited with animation. So we're going to look at some photos of the field and our seed collectors that were busting their butts in this hot Central Valley. You will see species up here that we amplified that went straight into a seed mix. And then this California milkweed I put in here. It was not in large quantities out in that valley, but definitely one to incorporate into our projects. And then we took that seed and we amplified it. Here's a few photos of the Heritage Growers operation. If you haven't come out yet, I strongly encourage you to do so. Here, I just wanted to emphasize that within this 2.5-year period, we did 214 collections capturing 93 ecotypes, spanning across 30 sites over 5 counties of this region. This built a diverse palette of 23 graminoids, 63 forbs, and 8 tree and shrub species. So, like I said before, this grant gave us a space to kind of do a really huge push of R&D for this region, and we learned a lot about native seed, collecting and amplifying it, and I wanted to highlight a few things. First and foremost, species availability and feasibility. We kind of learned that not all species are practical to collect or farm at scale in a conventional agricultural system. These 2 plants on the right-hand side, I'm highlighting in that point, widely abundant in this region, but some ecotypes tend to be a little bit finicky on our farm. And then on the other side, we have some key species that are super scarce on the valley floor, but we know are critical to incorporate into our plans, whether they are heavy pollinator species or culturally significant plants. These will require multiple years of collection in order to get enough to put on our projects. Genetics and ecotypic integrity. So we're learning that it's important to limit our generations in production. This allows us to maintain the wild conditions of our seed inventory, and isolating ecotypes of the same species prevents genetic mixing on our farm too. And then in our next steps of implementation, what's really cool about all of this is that we're going to be able to continue to monitor and understand the competitiveness of these new ecotypes that we're going to be bringing to the market.
So, Haleigh team are busy driving across the state of California, collecting seed, leaving no corner unturned. My team and I are trying to figure out, well, then how do we actually get the seed on the ground to be successful? And so in the past, our understory has been largely limited by plant availability, and we've relied on what we consider our 3 workhorse species, which are gum plant, mugwort, and creeping wild rye. And these species provide excellent forage and habitat. They compete well with weeds, and they've served us really well for all of our floodplain projects. But now, as we're expanding and diversifying into new ecosystems, it's really it's opened the door to many different possibilities. So that brings us to seed design mix. There's a lot of things to consider when you're thinking about creating a seed mix. First and foremost, you want to have local ecotypes. Secondly, you got to think about the hydrology. Is your site really flood prone? So maybe you need species that tolerate more frequent flooding. Maybe you want to think about the phenology and you want really extended bloom windows. And then there's interspecies competition. Maybe you have a one native species that's highly competitive, so you got to figure out how to balance that PLS rate within the seed mix so that it's not drowning out and out competing the other natives in that mix. And then I think it's really important to think about operationally. We drill seed a lot of our sites, and as you can see here, seeds come in all different shapes and sizes and densities. So we have to think about how can we make mixes that aren't going to clog our seed drills and we can get a uniform drilling across the site. And then of course, management strategies. How do we make seed mixes that are compatible with using herbicide as a management tool? And maybe that's the first year just doing a grass seed mix to get those grasses established. And then we can use a broadleaf herbicide to control from weeds and help our projects get established. And finally, we can't forget about scalability and cost. We're trying to do this at scale, so we need to be cognizant of not overcomplicating our seed mix designs so that the price tag kind of becomes a non-starter. And then finally, these 12 projects, we're not at implementation yet, but I want to touch on some key topics of how do we actually do this on the ground. And I just want to highlight seeding timing is super important. We take advantage and try and seed in the fall months. And this aligns really well with a lot of our sites coming out of agriculture. And then I just want to emphasize the importance in investing in multi-year irrigation and weed control to yield really successful project outcomes.
Okay, so what's the big deal? Well, we have broken through the native seed bottleneck in this region. It's not that simple. We can talk about that later, come find us. But really we're unlocking new species for this native seed market and achieving an economy of scale for high quality source identified seed.
And then why does this matter? Well, it matters because we're able to do projects like these and restore biodiverse native habitat at scale, and we can slowly start to patchwork together these critical corridors that not only benefit us as people, but all the wildlife that depends on these areas.
And this is just a reminder, as you see in a lot of presentations, that it takes a village of folks to get this kind of work done. So just wanted to shout out a whole bunch of our partners. We thank them from the bottom of our hearts. And with that, thank you.
Thank you, Haleigh and Annie. On to our last speaker. Did it? Sure. Let's see, I've got to find. Always a pain to find where this mouse is. Oh, there it is. Yeah, so updated. Okay. You didn't send me a new updated bio, right? Make sure.
No, I just brought that.
Okay. Yeah. So yeah, like Annie and Haleigh were giving me updated bios, and I was like, oh boy, this person. Yeah. Okay, sweet. All right. Actually, wait, I need to have this ready. There we go. Your bio. All right. Oh, wow. There we go. All right. Now on to our final speaker for this awesome trilogy of Riparian talks. We have Sarah Gaffney. Sarah Gaffney is a senior scientist at River Partners, managing, monitoring floodplain restoration projects. She received her PhD from UC Davis in ecology and has been a board member of the Cal Native Grass Association since 2020. And the name of the title, Estimating the Multiple Benefits of Riparian Restoration on Ecosystem Functions, Biodiversity Conservation, Water Quality, and Soil Health. Sarah Gaffney, you have the floor.
Today we talk about multiple benefits of riparian restoration. I'm going to skip the River Partners intro. So riparian areas provide multiple ecosystem services: water quality, carbon storage, biodiversity, soil health, shared landscape. So we ask a lot of them, and so how the way that we manage them has really important implications in the way that we restore them. You know, which ones are we trying to manage for? How is it possible to maximize all of these different goals that we have for them? And unfortunately, it's a little bit complicated, right? Because many of these benefits in several different ecosystems have been found to present trade-offs. So the figure to the right is from a riparian zone study in the US Midwest. And it finds that herbaceous matter, yes, can lead to higher organic matter, but also nitrate pollution, higher emissions, and lower bird diversity. And Christy DeBala from Point Blue has found that there are trade-offs here in California in riparian zones. So the greater tree density may favor increased carbon storage, but also that's to the detriment of bird diversity as well. So we really need to understand these trade-offs. And we're focusing in the San Joaquin Valley, and there's just hasn't been that much work on riparian zones in the San Joaquin Valley. And so as part of that planning grant that Haleigh and Annie were just talking about, we received funding to do a large baseline monitoring push. And so we went to 10 different planning sites and 10 reference sites to collect data on a bunch of biodiversity metrics. And notably, due to the paucity of sizable remnant riparian habitat in the San Joaquin Valley, two of our reference sites were chosen to be some of our older restoration sites. And so we were working with Point Blue to analyze all of our bird data that we're collecting, and they came to us really excited about wanting to do some soil data collection. And we're like, yes, please, because that's going to help us learn more about the various ecosystem services our restorations could be providing. Yeah, and so then we could have the research goals. How do mid and late stage restoration plantings compare to agricultural fields and remnant sites? What are the trade-offs and synergies among the services that we're looking at? And then we have our long-term goal of creating a baseline data set so that we can go back to our ag sites after they're implemented and do this all over again. And so I do want to note, right, that we don't have prior soil data on our older restoration sites pre-restoration. So while we're kind of talking about treatments as different various ages, it is possible that we can't causally associate that with age, but all of these sites are very close together spatially and have very similar soil types. And so we sampled 6 riparian sites that span a range of these restoration ages. They're all riparian sites located west of Modesto, right near the confluence of the San Joaquin and Tuolumne rivers. The first two are 2 agricultural fields. One is a conventional orchard, one is in silage, and we just completed planning and permitting for restoration of those 2 sites. At the time of the soil sampling, our Hidden Valley Ranch restoration was just a little more than a year old. Previously, before that, it was in row crops, so we're calling that our early stage restoration. At Dos Rios State Park, prior to restoration, was just a bunch of tomato fields. And it was restored on average around 9 years ago, so we're considering that our mid-stage restoration. And then in the San Joaquin River National Wildlife Refuge, just across the river, is the Viera Tract, which we restored around 19 years ago. And so we're considering that our late stage restoration. And then lastly, we have the Hageman Peninsula, which is a remnant forest, or remnant habitat, I should say. There's dense tree cover around the edges, right near the oxbow, but in the center, it's a lot more dominated by herbaceous cover. In February 2025, River Partners and Point Blue staff went out to collect soil samples at 15 spatially balanced points. We were looking at soil structure, so aggregation and bulk density, because we want, the more aggregation we have, the more space that we have for air and water flow and space for roots to go. We looked at, organic matter content, infiltration rate, soil moisture. That's good for drought resilient. When there's rainfall events, we want the water to stay in the soil and be available for our plants. And then also inorganic nutrients like available phosphorus and soil nitrate, which can have implications for water quality. We want them tied up in that organic matter and to be available for plants. We don't want them running off. Point Blue also went out to do the point center quarter method to collect data on woody tree biomass for carbon storage. And then River Partners was collecting data on bird species richness, vegetation, and pollinators. And so looking at the vegetation, we found that our restoration plantings were persisting long-term. There's no significant difference between the early, mid, and late stage restoration in terms of species richness. And, obviously they're higher than in agriculture because we planted them. But what is interesting is we found that our mid-stage 9-year restoration was more diverse than the Hageman Peninsula, which is our naturally occurring remnant site. In terms of native species proportion, again, the ag lands say significantly lower proportion of native species, but it is showing again persistence of high native species throughout all of our restoration years. And then moving on to soil health, we did find that there was the initial restoration planting caused some slight disturbance and some negative impacts. But at that 9-year mark, we saw substantial benefits to soil structure, fertility, and moisture dynamics. Again, not surprisingly, there was incredibly low soil organic carbon on our agricultural fields. It's a very typical value for the region. But we saw significant gains by 9 years of restoration. And the late stage restoration is essentially double that of the agriculture. We did find that in that 1-year restoration, we saw a jump in those inorganic nutrients. We were hypothesizing that they're residual from fertilizer applications in those agricultural fields, coupled with the lower nutrient demands of our restoration plantings. This could cause a problem, right, if there was a huge runoff event right after we planted, but also want to note that at the time we had seeded our understory only a few months before this data collection, and our understory really hadn't established yet. So it would be really interesting to do this again, if year 2, which we didn't do, but it would be nice. We saw improvements in compaction and soil structure following 9 years of restoration, pretty significant jumps. The decrease in bulk density happened somewhere in between that 9-year and 19-year mark. But again, this is really good for plant establishment, root health, and water infiltration. Infiltration rate and soil moisture also significantly improved following those 9 years of restoration. And this is going to hopefully improve drought resilience and lessen the potential for runoff. And then looking at carbon storage, we again saw those benefits detectable 9 years after our restoration plantings, but also interestingly, no detectable benefit observed in our remnant site. So this is that graph here. You can see that the bulk of the soil storage of carbon is in the soils, but we do have substantial woody biomass carbon storage in the mid-year and late-year restoration sites. Talking about animals, immediate improvement in our bird diversity, just 1 year after planting and providing those native plantings. But that was on par with all of the older restoration sites and the remnant site. We also saw an increase in pollinator diversity after those 9 years of restoration. And so to wrap all of this data up together in a way that can really make sense and interpret it, Lisa performed a multivariate analysis, which is a way to really see how dissimilar sites are to each other and understand what variables are driving those differences. So, and then we can also see if there are trade-offs between different services through this analysis. So each dot essentially represents, a sampling site, and they're color-coded by the type of site that they were at. And so you're seeing, the closer dots are together, the more similar they are. And you can see that all of our agricultural sites are just very clustered together. And then, when variables is overlapping with, one of these ovals, it means that there's a stronger relationship between those sites, and that variable or that indicator. And so you can see, again, clustered in the top right corner is our early restoration site. It's highly correlated with those negative impacts of higher compaction, higher nitrate, and higher available phosphorus. And then as you move counterclockwise, you see our light blue circle, which is our mid-year restoration site. That's when we're seeing improvements in vegetation diversity, infiltration rate, native percent cover vegetation, soil organic carbon. And then again, moving down just at our late stage restoration site, that's when we're seeing improvements in soil moisture dynamics and aggregation. So, as our restoration age increases, our metrics are becoming more similar to our remnant sites. Again, right, we can't like totally prove causality here, but this is a very strong, pattern. And then also what's really important here is that we're not seeing any trade-offs between all of the positive indicators of ecosystem health. So all of them are clustering on the left side of the graph. And so that if there were trade-offs, some of them would be pointing in the other direction. So main findings, our restoration plantings are successful long-term. We're finding ecologically significant benefits primarily at that 9-year mark of restoration. So we are finding that there is the initial soil disturbance of restoration does increase in organic nutrients following the planting, but it doesn't seem to be persisting long-term. And so next steps, right, this is supposed to be a comprehensive baseline data set. We're securing funding to be restoring our 2 agricultural sites. And then hopefully after restoration, we're going to keep collecting this data. So we actually have real before data compared to after data. A lot could be happening in between those 1 and 9 years of restoration. So we want to be sampling, maybe years 3 and 5 to figure out what's going on. And then also, right, we're kind of comparing everything to one remnant site right now. And maybe that one remnant site is not indicative of all other remnant sites. So we currently have a project going right now where Lisa is, I think she went back last week. She's going to a bunch of other remnant sites nearby to collect this same data. So hopefully we'll be able to update this and find out more. Thank you.
That is the point where we have all speakers come back up, and actually I'll take my chair to give them a seat. And time for questions. Yeah, I can just feed the mic to anybody in the audience and relay it back to the speakers. So, the questions. I saw the first hand was in the far back.
I have a question for Sarah. I know that you didn't necessarily do a lot of the soils work, it was not quite good, but did you consider at all including biological indicators, microorganisms in the soil, rather than focusing on just physical and chemical indicators? That was the funding issue, or is this something that you do in the future? Yeah, so actually, as part of this larger funding, we did a huge DNA sampling where we did a bunch of soil samples and looked at all life. And so we do have a lot of that. We do have that data, but we just didn't have time. By the time we got it, it wasn't enough time for Lisa to include it in the class. We hope to do that.
Also for you, just wondering if you have a theory why the soil carbon is lower at the site than the more visible sources.
I think it's just because a lot of the soil samples that they did were in that open herbaceous grassland area, and then the other sites had a lot more trees. So that's why it's maybe this isn't the best remnant site to look at. And so the other sites that we're going to, they're just smaller, not something you don't have any option.
There also was a really large fire
15 years ago in that site, so that might be impacted the release carbon atmosphere.
Thank you. My question is for Annie, about drill seeding. Qualitatively, my company has found that if you drill seed everything at the same depth, only certain species will grow back. How do you design your seed mixes to compensate for that?
That is a really good question. And I think a lot of times smaller seeds don't like to be drilled as deeply. So a couple things, I think grouping smaller seeds together and doing multiple drill seed passes might be the way to go. And also a lot of forb species, we do broadcast seeding. So it's just, it might take a little bit more time implementation wise, but I think it'll really help give all the different size, shapes and sizes of seeds a chance to grow.
I have a question for Neil. So you were talking about how dumping is done by like landowners. I guess they're trying to protect their lands from potential floods. I know you said you have to work with the water for a lot. Did you have to communicate with landowners, or you're saying like it's private, unpermitted dumping? Do you not have to communicate with them, or like how you selected those 6 sites that you guys ended up working on?
Yeah, so in this case, we're blessed by the fact that we own the property and we're able to say we're okay with some meander. We're okay with losing acres of these fields over time. But this is, I mean, finding opportunities to remove this kind of unpermitted trash on, you know, starting with the existing conservation lands where you're going to have a landowner who's presumably more willing to tolerate morphological changes over time, losing some acreage over time. When the sites is still in agriculture, that's going to be a struggle to get done for sure. And it is in this case, this project is not something we had to work through because it was already in restoration. Yeah, but I mean, that's probably the biggest barrier is folks understandably don't want to see the farm shrink over time. Yeah. So yeah, in this case, the ownership, various easements on the property. Yeah, that's why we want to crush this stuff because during flood emergencies, folks will trespass to take this material out of desperation. I've heard stories from local farmers of their driveway disappeared overnight. Folks jackhammering up, dumping it out on the riverbanks. So it's kind of a Wild West situation out there during flood emergencies.
Hey, my question is for Sarah. I was wondering about, I have 2 questions. One, do you have any targets that, for that you're managing the board? I might miss that, but I think you're doing a lot of changes. And I'm just wondering if they're like established kind of like, this is a pristine condition and this measure would be X. Is that something you guys have considered? Oh, I'll ask. Sorry, the rest of my question is the remnant sites. I'm wondering, I know you've already addressed this to some degree, but to what degree do you think the remnant sites are kind of like an ideal, like, wide state?
Great questions. For your first one, I know that like there's an ideal bulk density that was like 1.4, and that's for that soil type that was there. She was comparing to that. But no, I don't think we had parameters comparing to, mostly just trying to see how similar it was to the remnant sites. I don't consider the remnant sites to be like wonderful and ideal. You know, they still have a lot of pressure issues. I mean, we just are messed up hydrology. Like, there's never going to be, it's never going to be perfect. So, I mean, one of the things that I hope to see, right, is that maybe on some of our metrics, our restoration sites are going to be better than our remnant sites. And that shows that we're constantly increasing, because practice adaptive management, we're always trying to be better and better. One of the problems, right, maybe with like this late stage and mid stage restoration comparison, as we are doing it now and not doing it at the same sites over time, is that, you know, our restoration practices for Dos Rios were a lot better than our practices that we did track. So, you know, it's hard to see side apart.
Yeah.
Yeah, my question's for Neil. You mentioned that the crushed up concrete has value, or at least the state park. Does anybody else want, like, if there's an economic incentive, do you also like a recycling program?
Yeah, we could pay for the crushing and then the value of it to get worked in. If we paid for the sorting magnets, pulling out all the metal trash, getting it all cleaned up and crushed, there would be some value to basically sell it back and mix in as base aggregate. So I'm working with a local group, Modesto Sand and Gravel, who does a lot of this work to tease out those couple options. We have money in hand right now to crush about 5,000 yards of the material, and still looking for money to crush the other half. But limited value.
For Neil, you mentioned the cutting the green tape and then getting restoration. I'm kind of reluctantly a permitting nerd because it's really important part of these projects, and we're all doers and we like the doing and the being outside, but the permitting is super, super important. So as mentioned, working with the water board and not needing to do anything for, but what about like CDFW or any of your experience?
Yeah, we did work through a classic lake and streambed alteration agreement with CDFW. At the time we started that permitting, the new restoration management permit CDFW has been working on wasn't available yet. I would take that route if I were doing it again. Lake and streambed alteration is just more rigid framework, right? But yeah, so we hard to argue we're modifying the bank in this case. So LSAA, I think the beautiful thing about some of these cutting through tape efforts is they're trying to look. There's a recognized importance of net benefits, and that some temporary impacts are, you know, the juice is worth the squeeze. So yeah, had a great experience working through under the Sergo, as it really takes that net benefits lens from the top down, and like I said, recognized after some numerous interesting conversations, like the point is to induce erosion. There will be sediment in the river. Getting past that sort of roadblock and recognizing this is a natural part of the process here was fun. Yeah, and let's see, we also in this region, the Central Lake Flood Protection Board has a pretty robust encroachment permitting process. It's called encroachment. So in this case, this is actually considered an illegal encroachment, an unpermitted encroachment in the floodway, and we used our existing flood board permit coverage just under a simple maintenance authorization to go back out and pull off this unpermitted encroachment. So we actually wouldn't have needed a fresh encroachment permit per se. And so that's the added element of the benefits of targeting this kind of material, is it's already seen by the board as an illegal encroachment. They'd love to see it gone. As long as you have a landowner who, again, is willing to see that meander over time.
All right, that concludes that session. Give one more round of applause for our speaker.
Crisis?
Yeah, I saw that.
Good to see you again. Bison bucks.
Still on full battery, surprisingly.
Keep it up.
Exactly.
Good talks.
Thanks, Ina.
Good job.
Yes, now finally I can just disappear. Yes. All right, where to put this though, where it's not going to be in harm's way while lunch is happening? Where to put this? Oh, why not? Just sneak it here. It's not going to fall off. There. Yeah. What if you make your I live next door to the time? No, I was at WCP. So I didn't buy doctor registration. Just happened the first year after training. What was happening? Cash Creek down there happening. Yeah, it's awesome. And it's not so much better. Yeah. So I think that's it. Okay. Oh yeah, Phil was hired. Yeah.